Objective 3. Compute at least probabilities. Usually, when computing probabilities involving the phrase at least, use the complement rule. The phrase at least means greater than or equal to. For example, a person must be at least 17 years old to see an R-rated movie. This means that the person's age must be greater than or equal to 17 to watch the movie. So remember, at least represents greater than or equal to. Okay? Now, if before we move any further, let's say we were talking about at most. If we said at most, then this would mean the opposite of that, which would be less than or equal to. Okay, so we want to make sure that we understand both the significances between those two. At most is less than or equal to. Okay. Now, let's take a look at an example, computing at least probabilities. The probability that a randomly selected female aged 60 years will survive the year is 0.99186. Okay, so that's the probability that a female aged 60 years will survive that value, according to the National Vital Statistics Report. We want to find what is the probability that at least one of 500 randomly selected 60-year-old females will die during the course of the year. So we need to be careful of this question. So we're looking for, okay, the probability that at least one of the 500 randomly selected 60-year-old females will die during the course of the year. Okay, so again, will die during the course of the year. So the phrase at least, again, means greater than or equal to. So we want to know the probability that 1 or 2 or 3 or all the way to 500 60-year-old females will die during the year. Now, these events are mutually exclusive. So writing this out, the probability of 1 or 2 or 3 all the way to 500 will die would mean taking the probability of 1 dies plus the probability of 2 die, probability of 3 die, and so on all the way to probability of 500 die. Now, if we wanted to compute these probabilities, which we can, this would be very time consuming. However, noticing that the complement of at least one dying is none die, or all 50 survive. We're going to use the complement rule to compute the probability. So, again, we're looking at the question, okay, the probability that at least one dies. So that means we're going to take 1, okay, and then subtract the complement that the probability of none dies. So we're going to take 1 and then subtract the probability that the first survives and the second survives all the way to the 500th survives. So that means we're going to take 1 minus the probability that the first survives times the probability the second survives. So what we're doing is we're taking the value of 1, okay, and then we're going to subtract, so we're taking 1, and then we're going to subtract the probability that's given in the problem, which is 0.99186. And then if you notice that we would be taking each one and then multiplying it together 500 times. So we're going to raise it to the 500th power. So what we would do is we would come into our calculator, we're going to take 1 and then subtract. We're going to take the value in parentheses, 0.99186, okay, and then we're going to raise that to the 500th power. and then that gives us the following result raised to 4 decimal places. So it's going to be 0.9832. So again, converting this to a fraction would be the following. So if we round that to 3 decimal places, this would give us 0.983, and then writing that as a fraction would be 983 over 1,000. So we would say that if we randomly selected 500 females, 60 years of age, 1,000 different times, we would expect at least one to die in 983 of the sample. Okay, now let's take a look at the summary, meaning the rules of each probability that we've dealt with. Okay, rule number 1, the probability of an event must be equal to 0 and 1 inclusive. That means if we let E denote any event, then the probability of event E must be in between 0 and 1 inclusive. Rule 2, the sum of the probabilities of all outcomes in the sample space must equal 1. That is, if the sample space is equal to all these events, then the probability of each event, when you're adding them together, should equal 1. Rule number 3, there were 2 parts to this rule. Okay, the first part is that if events E and F are disjoint events, meaning that they do not have anything in common, then the probability of event E or F is equal to the probability of event E plus the probability of event F. So remember that if they are disjoint in this scenario, we're going to use this formula. Okay, now if events E and F are not disjoint, meaning that they have something in common, then we're going to have to use this formula, meaning the probability of E or F is equal to the probability of event E plus the probability of event F minus what they have in common, hence the word and here. Rule number 4, if event E represents any event and the complement here, E to the power of C, represents the complement of that event E, then the probability of the complement is equal to 1 minus the probability of event E. And if rule number 5, if event E and F are independent events. So keep in mind that if it's independent events, then we're going to use this rule. So that means we're taking the probability of event E and F, and it's going to equal the probability of event E times the probability of event F. Notice that OR probabilities use the addition rule. Okay, so we can see here that the OR probabilities use the addition rule, whereas the AND probabilities use the multiplication rule. Accordingly, OR probabilities imply addition, whereas AND probabilities imply multiplication.